So the first question is this one that we actually looked at over here and then punted on. If we have g of x equals 2x to the, let's say, fourth over x to the 1/3. It's really tempting. You want to make it so you can just do ratio, but it doesn't work. So if you're going to use power rule, you have to make it so it fits the power rule form. So I need to use algebra first to clean this up. So then I need to rewrite this. Now I'm not taking the derivative yet. All of this is just algebraic simplification that I have to do. So I have g of x is equal to 2x to the fourth times x to the negative 1/3. Remember that things in the denominator can be brought up if they're negative exponents. And then I can rewrite again. I can combine these exponents to do g of x equals 2 times x to the 4 minus 1/3. Now I have to think back to a long time ago when I tried to do 4 minus 1/3. And hopefully someone told me that I could rewrite this as 4 times 3 over 3 minus 1/3. This is getting a common denominator, so I can simplify this number. So I have 12/3 minus 1/3, which is 11/3. So I'm still doing algebra here. And I have g of x equals 2x to the 11/3. All of this is algebra needed, or actually arithmetic needed, to simplify the exponent. So have I done anything with the derivative yet? No. All of this has been algebra to clean it up. Now that I've done this algebra, now it matches a form I can use. So before we do the derivative, are there any questions about how we got from here to here? So now g prime of x, if we go to do power rule, I can keep the 2 where it is. I can bring the 11/3 down. And I can do 11/3 minus 1. And I'd really like to make it, again, look 11/3 minus 1. So 11/3 minus 1 is 11/3 minus 3 over 3, which is 8/3. So I have g prime of x is equal to 2, or I can do 22/3 x to the 8/3. There's a lot of algebra here before I even start applying power rule. Once I start applying power rule, the 2 just stays around because it's a constant multiple.